In light of the 21st century, the world is facing serious challenges regarding energy sources and energy consumption. Each year, the world's electricity consumption increases as well as the production of electrical devices. Nowadays, our planet's use of electricity is mostly generated by fossil fuels, which is one of the main reasons of climate change. Although renewable energy has been proven to be the cleanest source, it is not used widely enough and taken advantage of efficiently. Thus, in our project, we decided to suggest an optimal solution to tackle these global issues by finding a way to take full advantage of renewable energies. The most popular energy systems are solar panels, so in order for us to harmonize with people's needs and preferences, we decided to make solar panels more efficient by maximizing their energy inputs. Normal solar panels absorb the energy that they get from the sun and converts it into electrical energy. The sun, whose position is not fixed due to the rotation of Earth, makes the absorption temporary and thus the energy minimized. So this is where we came up with the idea to make our own solar panel that tracks the sun rays in order to maximize the energy. Using a sun tracking solar panel is, in our opinion, a very much needed upgrade since the use of renewable resources is increasing, which made us think of creative ways to use existing resources and make them more efficient and well structured. The importance of these matrices lies in the fact that they helped us make complex decisions and craft arguments to defend the decision that we made. Both these matrices helped us choose the fourth model, which got the highest total in both matrices. This is how our tracking solar panel works. The sun rays reach the solar panel, which triggers the LED detectors that give a signal to the microcontroller in order for it to rotate the servo motor and thus shift the whole solar panel towards those sun rays. Our product obviously takes into consideration many factors, including societal factors. Our design is very beneficial for society members. It is safe and environmentally clean for all kinds of households to power the appliances. Our design is easy to operate, which will make the instructions very clear for the customers. It causes no harm for people of the society. Our design will involve different technical materials, including an Arduino, a servo motor, a breadboard, wires, a solar panel, and LED tracking sensors. The technology of our design is clean as it uses solar power and it is efficient. It is also common in the Moroccan market as it is available in different shops and for very affordable prices. Although some of the material is not eco-friendly, but it is recyclable and its service life is estimated to be more than 7 years, so it minimizes waste of material. Which brings us to environmental factors that we took into consideration and that proved that since our design is based on avoiding fossil fuels, then it is environmentally clean and it protects the nature from further pollution. We also took into consideration economic, legal, political, as well as ethical factors in order to achieve the best version of our design. There are many competitors to our design in the market, of which we chose these two, which after successfully conducting a competitive benchmarking, we could see that our design has the same main functions and purposes of both models, as they all aim to track the sun's positions throughout the daytime to maximize the output energy. However, we noticed differences between our design and these other designs when it comes to their weight and pricing. Our design has been proven to be lighter and cheaper, which puts it in huge advantage. By this comparison, we were able to prove that our design is more reliable, safe, and efficient. TSP follows many other engineering design processes such as project management, requirement prioritization, functional analysis, specifications, concept development, as well as embodiment. Here is our TSP's function structure, where the functionalities work after providing it with the input, which is the sun rays. In order for the circuit to perform its functionalities, we must provide it with power. The first functionality is detecting the direction of the sun rays and then rotating the panel accordingly, which means to the direction of the sun rays, capturing the light energy and then converting it into electrical energy, which creates an electrical field that gets distributed for the user.
So, I will show you here how our solar panel works. I'm gonna use light as an alternative to sunrise or sunlight. Okay, let's give it a try. If the light is in the right direction, right, left. Okay, as you can see, our solar panel works perfectly. Let's move to the components. We used a support to hold our panel that contains two servo motors, as you can see, one for the right direction and the other for the X direction. We used two MH series sensors that this one will capture light from the right direction and this one from the left direction. Okay, and here we used a breadboard to have multiple 5-volt and ground pins, because the Arduino has just two ground and one 5-volt. We used an Arduino to code our solar panel, and here is the code we used.
After going through the customer requirements analysis, we translated them into engineering specifications and associated each one with a specific solution concept. To clarify all of this, we built a chart representing embodiment with EDP. We focused on the portability, maintenance, and affordability, and finally the shape. For the first one, we knew that our design shouldn't be too heavy, so we chose the lightest solar panel, thin film. For the second one, we knew our design had to be affordable and had to be long enough lifespan. So we chose the cheapest servo motor that has a 7+ year lifespan. And finally, for the shape, we chose the least amount of material and that aesthetically goes together and is pleasant to look at. For the cost analysis, to minimize the cost, we will need to rent an office in Agadir for $100 and a storage room for $200. We will also hire 3 technicians as a starting point with a salary of $400 each. To manufacture our project, we will need wires for $5, a solar panel that will cost $173, sensors for $10 each, an Arduino that costs $20, and finally a servo motor that costs $100. So to get these components, we will work with 2 suppliers, Sana Energy for solar panels and Electroma for all the other components. So the final price for our TSP would be $400. And this is our business canvas for more detailed information. TSP, going solar for a brighter tomorrow.